All right, this is page 2 of the probability test 1 review. So looking at number 9, it says there are 120 people at a meeting. They each give a Valentine's Day card to everyone else. How many cards were given? Well, since there's 120 people, and each of those 120 people will give out 119 cards because they give a card to everyone else. And of course, they would not give a card to themselves. So 120 people times 119 cards is 14,280 cards that were given. All right, number 10, it says find the probability of each event. And this is going to be using the binomial distribution formula. It's just NCR times the probability of success, P times, that should be 1 minus P, not P, but 1 minus P times the N raised to the N minus X. So, so this is probability of success, this is probability of failure, all right? So in this case, we have a fair coin that's flipped 7 times. What is the probability of the coin landing tails up exactly 2 times? So N is how many events, and 2 is how many successes that you want. So this is going to be 7C2. And then the probability of success is 50%, because when you flip a coin, you have a 50-50 chance of tails landing up. So that's 50% success raised to the second power, because you want it to happen twice. And then there's also a 50% failure possibility, and that could happen 5 times. So that's raised to the 5th. And you just put all of this in the calculator at once. 7C2 times 0.5 to the second times 0.5 to the 5th. And you get 0.164, which translates to 16.4%. All right, number 11, a basketball player has 50% chance of making each free throw. What is the probability that the player makes exactly 3 out of 7 free throws? All right, using the exact same formula, probability distribution formula, you have 7 events happening, 7 free throws. We want to know the probability of making 3 of them successfully. So that's 7C3 times 0.5, because it's a 50% chance of success, raised to the 3rd power, because that's how many successes we want, and then 50% chance failure, and then that would happen 4 times. And you notice the 3 plus 4 gives you the total of the 7 events. All right, put all this in the calculator, and you get 0.273, which converts to 27.3%. All right, number 12, a 6-sided die is rolled 9 times. What is the probability that the die will show an even number exactly 2 times? All right, so using the exact same formula as before, we know there are 9 events because the die is rolled 9 times, and there's 2 successes. At least we want 2 successes. So that's 9C2. And then the probability of getting an even number is 50%. Why is that? Because there is 3 even numbers on a die, and there's 3 odd numbers. So that would be 3 out of 6 probability, which is 50%, or 0.5. So that's why we have 0.5 here, and that's raised to the 2nd power because we want a success to happen twice. And then we have 0.5%, or 0.5 is also the failure probability, and that would happen 7 times. And again, the 2 and the 7 together add up to the 9 total rolls. All right, put all this in the calculator, and you get 0.070, which is 7%. All right, number 13 says a 6-sided die is rolled 10 times. What is the probability that the die will show an even number at most 8 times? Now, if it shows an even number at most 8 times, that means that it can show an even number 0 times, or 1 time, or 2 times, or 3 times, or 4, or 5, or 6, or 7, or even up to 8 times. So if we were doing this, calculating this the long way, we would have to calculate the probability of 0 times, the probability of 1, the probability of 2, all the way up to the probability of 8, and then add them together. Or we could do much less work by doing the probability of 9 and the probability of 10, adding those and subtracting from 100%. And that's the more efficient way of doing this. So, again, the probability that it will happen at most 8 times is the same thing as finding the probability that it happens more than 8 times, which would be 9 times or 10 times, because, the die was only rolled 10 times. So probability 9 times or 10 times added together, subtracted from 100. So that's what we're going to do. So we're going to find the probability of rolling it 9 times, probability of rolling it 10 times, and then we're going to add that together. So probability of rolling 9 times would be 10C9 times 0.5 to the 9th times 0.5 to the 1. All right, now the 0.5 again is because we're talking about rolling an even number, and there are 3 even numbers out of 6, so that's 3 out of 6, which is 50%, or 0.5. All right, so we put this in the calculator and we get 0.00977. And we find the probability of it happening 10 times, so that's 10C10 times 0.5 to the 10th times 0.5 to the 0. And we get 0.000977. And we add these two together and we get 0.0107, which is 1.07%. So that's 1.07% of happening more than 8 times. So the probability of it happening at most 8 times would be 100% minus the 1.07. And we get a final answer here of 98.93%. All right, and number 14. A quiz consists of 7 multiple choice questions. Each question has 4 choices. A student who forgot to study guesses randomly on every question. What is the probability that the student answers at least 2 questions correctly? All right, so the probability of answering at least 2 questions correctly means that that you'd be adding that you could possibly have 2 or more. So that's the probability of 2 questions, 3 questions, 4 questions, 5 questions, all the way up to 7 questions, which means we would have to find the probability of each of those, 2 through 7, add them together. Again, the more efficient way of doing it is to simply find the probability of less than 2 and subtract that from 1. And that's what we're going to do. So it's 1 minus the probability of less than 2, which is 1 minus the probability of 0 plus the probability of 1, because those are the 2 that are less than 2. All right, so then we need to find the probability of 0, which is 7C0, times 0.25. And the reason why that's 0.25 is because there's 4 questions, and only one of them is right. So that's 1 out of 4, which is 25%. So you have a 25% chance of success if you randomly guess. So that's 0.25 raised to the 0, and then 0.75 would be the probability of not getting it correctly. Because if there's 1 correct answer, that means there's 3 incorrect answers. That's 3 out of 4, which is 75%, or 0.75. That 0.75 is raised to the 7th power. We put that in the calculator and we get 0.133. Now we come down here and we do probability of getting 1 correct would be 7C1 times 0.25 to the 1 times 0.75 to the 6. And that gives us 0.311. We'll add these two numbers together, and we get 0.444, which translates to 44.4%. And then in part C here, we will subtract from 100. So 100 minus 44.4% gives us the probability of 55.6%. That's the probability that the student answers at least two questions correctly.